Okay, hello everyone. This is the second video for EGME 541, the ANSYS and ANSYS Workbench videos. This is like a mini solution for the first project we did for the class. As you see, this is how it looks like. We have an object that has a length of 20 centimeters in total, has a tapering cross-section area, and the radius at any given point with respect to the coordinate reference is given as y is equal to 0.01 times x minus 30 squared. If you remember, the main problem we had for our project was this force F1. We didn't have any problem with applying the other boundary conditions. For example, we didn't have any problem with setting the left part of the object as the fixed support and then applying a force right at the right end. But then applying a force at the middle, it would just give us problems. The solution for that problem was making the object as a stepped type of modeling and then applying the force to one of the rings as a solution. Another way of doing it is by freezing the first half of the material and applying the force to it, and then building the second half on top of it. By freezing the first half, ANSYS wouldn't give us any error. In other words, the ANSYS is going to treat the first half of the object as a ghost, something that really doesn't exist, but at the same time it does. So when you construct the second part of the model, on top of it, it's going to assume they're bonded together. But since the first half is being treated as a ghost when it's being frozen, it allows you to apply a force right at the middle. So the first thing I will do is I will assume, since this is like a 20 centimeter total length, I'm going to divide it to lengths of 2.5 centimeters. So we are going to have 9 nodes in total. Okay, so I'm going to use an Excel file, and these are going to be the points that we are going to use. The first node is going to be node 1, and I'm going to go and add 1 to each consecutive node. And as you see, we are going to have 9 nodes. The x, or the horizontal distance of first node with respect to reference point, is going to be 0. The second node is going to have a distance of 2.5 centimeters. So each node is going to have 2.5 centimeters added to its distance from the original reference from the coordinate system. So this is going to be 2.5 centimeters plus the point before it. And as you see, the end node is going to have a distance of 20 centimeters with respect to a coordinate system. And the radius, according to what we are having from the project, is going to be equal to 30 times this value minus 30 squared. I'm sorry. This is going to be 0.01. All right. So the radius initially is at 9 centimeters and eventually is going to be tapered to 1 centimeter as the final value. We're going to use these values, these numbers, to construct our object. Okay. So let's go to our workbench itself. And this is going to be our original workbench, so we are going to go with geometry. Okay. So this is the geometry we have. Right away, we will go and change the units to centimeter. And we will go to XY plane and look at it this way, normally perpendicularly. And the first thing we will do is going to sketching, line, and as you know, again, from the Excel sheet that we created, the radius initially is going to be 9 centimeters. So we will draw a line, and we know that we have to note the length of it is going to be 9 centimeters. So we are going to assign 9 to it, and then we are going to construct the other ones. Draw a line. So I'm going to go with another line. Okay. And then the second point from what we had from Excel sheet is going to have a distance of 2.5 centimeters from the y-axis or from the original reference point, and it's going to have a radius of 7.5625 centimeters. All right. So therefore, we will go to dimensions again. The horizontal direction of the horizontal distance of this point with respect to y-axis again is going to be 2.5 centimeters, and the vertical distance of it is going to be the radius, which is 7.5625. So 7.5625. All right, and then we will go for the drawing another line. All right, so right here. Again, we are going to, from the Excel sheet we had, is going to have a distance of, a horizontal distance of 5 and radius of 6.25 centimeters. So we will go to dimensions, horizontal, this point with respect to our y-axis is going to be 5, and the vertical distance is going to be V5 or 6.25 from Excel sheet we have. We are going to have to draw another line. There you go. Let's go and give it dimensions again. Horizontal, it's going to be distance of this point with respect to, I apologize, horizontal again, the distance of this point with respect to, I don't know why it's giving us error, again, this with respect to y-axis. Alright, so it's going to be H8, and it's going to be 7.5 centimeters, and then we are going to have a vertical distance of 5.0625 from the Excel sheet. And this is going to be the last line of the first half of the object. So we are going to go to dimensions, horizontal, and this is going to have a distance of, let's say, 10 centimeters, and a vertical distance of 4 centimeters. Okay. Okay, so now we are ready to construct the first half of the model. Therefore, we have to make the area an enclosed one. So I will draw a line from this point to x-axis, and then we'll complete it as such. I will generate the sketch. So now we are able to revolve it around the x-axis. Automatically, sketch 1 is going to be picked up. Axis, we are going to go with x-axis and apply. And we are going to generate it. As you see, the object is already working now. The second part, or the next step, will be going to the main part of the ANSYS and setting up the model. Okay, when it's being populated or when it's being published, we are going to see the project, the same geometry that we created like a couple of minutes ago, a couple of seconds ago, and you will see it here. Okay, so now we are able to apply the fixed support condition for this side of the object and apply a force of 1500 newtons. Uh, so far, we are not seeing any difference compared to the solution that we tried to apply for the first time. So we are going to go to static structural, insert force, and static structural, insert fixed support. For fixed support, we are going to apply this for the geometry. We are good now. For the force, we are going to choose this force for the geometry and a force of 1500 newtons, and the direction is to the right, or the positive direction for the x-axis, so that's okay. We are going to go to apply. Again, so far everything is the same as what most of the people did, but then we will get error if we try to construct the second half of the object and build it on top of the first half. It's going to say, hey, how are you going to apply that 1500 newtons of force? In order to fix that part, we will go to our geometry again. And remember, we are going to choose Revolve 1 and go to Tools and freeze it. Again, now that you have chosen this object as a frozen part and the sign for it is this ice cube, it acts or treats the object as a ghost. So it allows you to apply a force right here at this node to be equal to 1500 newtons and then build another object on top of it. You're not going to get any error anymore. So let's go here and then let's try to move the object. Okay, now we are going to go to XY plane. We have created the sketch 1 already. So let's build another sketch in XY plane, which is going to be completely independent of the first sketch. So sketch 2, now with sketch 2, we are going to construct the second part or second half of the object. So we are going to go to the sketching, line, and okay, right here, another line. Okay, again, the distance of the horizontal distance of this point with respect to y-axis is going to be 12.5 centimeters with a radius of 3.0625 centimeters. Okay, so let's go to dimensions, horizontal, this point with respect to y-axis, it's going to be 12.5, and the vertical distance of it, as we checked, is going to be 3.0625. All right, then time to make the or draw the other line, the next line. So again, based on what we have from the Excel sheet, a distance of 15 centimeters and a radius of 2.25. So let's go to dimensions, horizontal, this, with respect to, okay. So H14 has to be 15, and the vertical distance of it would be V15, which is 2.25. All right. Then we have 2 more lines left, so let's draw them really fast. It's going to have a 17.5 centimeter distance from the y-axis. So dimensions, horizontal, this point with respect to y-axis is going to be 17.5. and a vertical distance of B17 is going to be 1.5625, according to what we have from the Excel sheet. And then the last line is going to be this line here. Dimensions, horizontal, this point with respect to horizontal is going to be, let's see. H18 is going to be 20 centimeters, and the vertical distance is going to be 1. All right, so we are ready to enclose the area. Draw a line. Okay, so now let's revolve this new sketch 2. So we will go and generate the model that we created a couple of seconds ago. Then we are going to go to revolve. Sketch 2 is going to be automatically picked. And then for axis, we are going to go with this x-axis. So we are going to go generate it. And as you will see, although this is a homogeneous material, so you have to have the same material, you're seeing two different colors. So normally this would be picked as just one single object, but then if you do not freeze the first half, as you see, it won't allow you to apply that 1500 newtons of force at the middle. So now you're ready to go to the model. Go to geometry, update the geometry from the source, right click on the geometry, update geometry. All right. Do you see this force here and fixed support? We are not getting any error. Otherwise, it would give us an error or a question mark next to the symbol. So now we are ready to insert another force. Click on it. It's the last force is going to, the geometry we are going to use this tip, the face, a force of 500 newtons. And the direction of it is going to be to right in the positive direction of x-axis. So that's completely correct. Apply. So we are now ready to solve the system. You'll go to solution. Let's say, for example, we are looking for deformation, a total deformation. And let's say we are looking for, we will go to probe. We are looking for the reaction forces, probe, force reaction, and that yellow highlighted area, we're going to go with fixed support. So now let's go and solve the model. All right, we are getting correct check marks here. That means there is no problem. This is for the reaction force, as you see, is exactly correct. 1500 newtons plus 500 is going to give you a 2000 newtons to the left for the reaction force in order to cancel out 1500 plus 500. And this is your total deformation. You can see the deformation live with respect to time if you go and click on the plate button. The force, both of the forces are going to be increased linearly as ramp functions, and you see what's happening in terms of the deformation of the object with respect to time. All right, so that was it. Really, really important thing is when you are trying to construct these points and draw the lines, sometimes it will automatically try to guide you to draw a line that is parallel to another line or is either vertical or horizontal. You have to avoid that, because if you go with those options, it will not allow you to give dimensions to the point, because it's going to assume that you are going with, let's say, a parallel line with respect to another line, and it's going to tell you you are going to over constrain your system if you try to give it a different dimension. So that's it. I hope you found the solution to be useful, and we will go for the next video from here. Thank you.